So now to the second part of differentiation, right? So there are certain rules, certain rules that you're going to use when you're differentiating different functions. So they'll come in different forms. The functions will come in different forms, right? So we're going to look at how you're going to approach those different forms of functions, right? So we're going to look at rules for differentiation, right? For differentiation, differentiation. Okay. So we're going to look at the chain rule. So we're going to look at the chain rule, and then we're going to look at the product rule, and then lastly we're going to look at the quotient rule. We're going to look at the quotient rule, right? So let's start by looking at the chain rule. So we're going to start by looking at the chain rule. Okay. So it is used, the chain rule is used to differentiate. So it's used to differentiate functions of a function of a function of the form, a function of the form y is equal to f g of x. So function of a function. So if you have a function of a function, we're going to use the chain rule to differentiate function of a function, right? So dy dx, in general, dy dx is equal to dy du times du dx, right? So that's what we're going to use. We're going to differentiate, right? So using y is equal to g of x. G of x is going to be our u, right? And then y is going to be f of u. So it's going to be our f of u. We're going to differentiate u with respect to x and y with respect to u, right? So that's how we're going to do it. Let's look at an example. So we're going to look at an example. Differentiate with respect to x, y is equal to x squared plus 5 to the power 10. So we're going to differentiate y is equal to x squared plus 5 to the power 10, right? So this is a function of a function. So in this form, it's a function of a function, right? So we have y is equal to x squared plus 5 to the power 10, right? So we're going to let u, so u, so we're going to let u is equal to x squared plus 5. So the bracket enclosed, the function enclosed in the bracket, that's what we're going to substitute for u. So u is equal to x squared plus 5, right? So remember this this formula, dy dx equals dy du times du dx, right? So we have a function in u and x, so which means du dx is equal to du dx. If we're finding the derivative of x squared plus 5, so x squared becomes 2x, and then the derivative of a constant, remember, it's 0, so it means du dx is equal to 2x, right? So y is equal to u to the power 10. If u is x squared plus, so y is equal to u to the power 10, meaning dy du is equal to 10u to the power 9, right? Remember, we drop the power and then we subtract 1 from the power, so it's 10u to the power 9. That's dy du, right? So now going back to this formula here, so dy dx is equal to dy du, remember, it's 10u to the power 9, right, times du dx is 2x, right? So which means we have 20x u to the power 9, right? And then we substitute at the end. If u was x squared plus 5, so which means we have 20x bracket u is x squared plus 5, then to the power 9. So that's how we differentiate a function of a function using the chain rule, right? So moving on to the product rule. So I'm moving on to the product rule. Okay, product rule, right? So a product rule is used to differentiate a product of two functions, right? So it's used to differentiate a product of the form. So if a product of the form y is equal to uv, right? So these are two functions. U is a function and v is a function. Okay, so where u and v are functions of x, So u and v are functions of x. So meaning dy dx is given by v du dx, right, plus u dv dx. So that's the general expression that's going to give us the derivative if we have a product of two functions, right? So we're going to look at examples later. Let's just do the quotient rule, then we do examples, right? So we're going to look at the quotient rule. Right? So is that the same as like this was a product. No, the quotient is a division of two functions, right? So it is used to differentiate. A function of the form. So we use to differentiate a function of the form y is equal to u over v. So y is equal to u over v, where u and v, obviously, u and v are both functions of x. Are both functions of x. Right? So meaning dy dx, with dy dx is equal to v du dx minus u dv dx over v squared. So that's the expression that's going to give us the derivative, right? So dy dx is equal to v du dx minus u dv dx, all divided by v squared, right? So lastly, we're going to look at differentiation. Before we look at examples, right? We're going to look at differentiation of a certain function of ax plus b to the power n, right? So if a function like this, if a function of like this, ax plus b to the power n, right? So if y is equal to ax plus b to the power n, right? So dy dx is given by na, so the power multiplies the derivative in this case, right? So it's na, then ax plus b to the power n minus 1. So we just drop the power, which multiplies the derivative inside the bracket, right? So those are the rules for differentiation, right? So those are the rules for differentiation. Let's look at we're going to look at a few examples. Let's look at a few examples, right? examples, right? Says differentiate with respect to, so I want to differentiate with respect to x. The following functions. A, I want to differentiate x cubed, right? 3x plus 2 squared. And then B, I want to differentiate x squared plus 2 over 3x plus 1. And then C, want to differentiate ln x squared plus x. Want to differentiate ln x squared plus x. Okay, so let's get down to business. The first one, right? Also the solutions. Okay. So for the first one, A, want to differentiate x cubed. So y is equal to x cubed, 3x plus 2 squared, right? X cubed, 3x plus 2 squared, right? So as you can see, this is a product of two functions. So as you can see, so this is a product of two functions, and we're going to use the product rule, right? Remember your product rule. So it says what? We have v du dx plus u dv dx, right? So these are both functions, right? So we can say u is equal to x cubed. So that's our u is equal to x cubed, meaning du dx is equal to 3x squared. Remember, we drop the power and then subtract 1 from the power. So we are left with 3x squared, right? And then v is equal to 3x plus 2 squared. So that's the function, 3x plus 2 squared. And how do we find the derivative? dv dx. So that's the technique we just did earlier, the last technique we did, right? So of that, so which means that we drop the power, which multiplies the derivative inside here. So it's 2 times 3, right? And then 3x plus 2 to the power 2 minus 1. So we subtract 1 from the power. So which means we have 6, right? 3x plus 2. So 6 3x plus 2. That is dv dx, right? So meaning dy dx, meaning dy dx, right, is equal to v. The function v was 3x plus 2 squared, right? So it was 3x plus 2 squared. Now we're just substituting in this formula. This is the, so v du dx, what is du dx? Du dx was 3x squared, right? Plus u was x cubed times dv dx were 6, then 3x plus 2, right? So which means we have 3x squared bracket 3x plus 2, right, squared plus 6x cubed, right, 3x plus 2, right? So if you wish to simplify further, you can simplify further, right? Just break the bracket, right? And then you simplify further. Now for the second part, right, for the B part, right, B, want to simplify, want to find the derivative of what, that one. So if y is equal to x squared plus 2 over 3x plus 1. So that's a division of two functions, right? So it means it's u over v, right, where u and v are both functions of x. So we're going to use the quotient rule, right? So what does the quotient rule say? The quotient rule says that dy dx is given by v du dx minus u dv dx over v squared, right? So our u is equal to x squared plus 2, right? So u is equal to x squared plus 2, which means du dx is equal to 2x. If we find the derivative of x squared plus 2, x squared will give us 2x. Then if we find the derivative of 2, it's 0. So du dx is 2x, right? And then v is equal to 3x plus 1, meaning dv dx is equal to the derivative of 3x plus 1, right? So the derivative of 3x plus 1 is 3. Since if you div 1, it's 0, then 3x is 3, right? So 3x plus 1 is 3. Now we are slotting into the formula, right? So now just slotting into the formula. So dy dx is equal to v. What is our v? V is 3x plus 1, right? So it's 3x plus 1, which is multiplied by du dx. Du dx is 2x, right? Minus, what is u? U is x squared plus 2. X squared plus 2, which is being multiplied by dv dx, which is 3, right? So this is all divided by v squared, which is 3x plus 1 squared, right? So and then we were going to simplify, right? Here we have 2x and then 3x plus 1, right? Minus 3x squared plus 2, right? All over 3x plus 1 squared, right? So if you wish to simplify further, you can expand the brackets here on top and then simplify further, right, to give it in its simpler form, right? In its simplest form. So then let's do the last example. It's ln x squared plus x, right? So if we have we have ln x squared plus x. So we have ln x squared plus x. Remember when we did differentiation of logarithmic functions, right? We said dy dx is equal to derivative of the function over the original function, right? So that's the general form for the differentiation of logarithmic functions, right? So which means f of x is equal to x squared plus 2 plus x, sorry. So which means the derivative of this function is 2x plus 1. It's 2x plus 1. X squared, we get 2x. Then the derivative of x is 1, right? So which means we're going to have dy dx being equal to the derivative is 2x plus 1 over the original function, which is x squared plus x. So that's the answer. So we'll stop here for today, and then next time we're going to do the differentiation of different functions, such as we're going to look at parametric functions and implicit functions. So we're just going to do it implicit functions and parametric functions. Then we'll be done with differentiation. Then we'll move on to the applications of differentiation. So thank you for the lesson. So we'll end here for today, right? See each other next lesson, right?